right, so last class, at the end of the block, we talked about sum and difference of cubes, and we have formulas for those, and we just did one in the opener. That is one example of doing some higher degree factoring. We factored tons of degree 2 things, quadratic things, but now we're moving into these higher degree things. So let us look at something different than sum and difference of cubes. For example, number 1. Let's go with x squared. How about plus, oh, I'm going to make this x to the 4th. I already made boo-boo. X to the 4th plus 13x squared plus 36 equals 0. Okay. Well, so first of all, let me start by saying, with any factoring, you need to set the equation equal to 0. So this one's done for us, but if it's not equal to 0, that is step 1, make it equal 0. And when you do that, try to keep your leading coefficient positive, like your highest power positive. It's just going to make things easier. So this is a 4th degree. There's no common factor. If there was a common factor, I would like factor out the common factor. We've seen that happen before, but there isn't one because it just isn't. So here's the deal. We call this using quadratic form. Not quadratic formula, quadratic form. And here's what I mean by that. You kind of, for a minute, you want to say to yourself, gosh, x to the 4th, I don't know. But what if that was just an x squared? So what if it was x squared plus 13x plus 36 equals 0? That we could factor all day long. And that's easy to factor. I look at that and I say, can I find numbers that have a product of 36 and a sum of 13? And the answer is yeah, I can. 9 and 4. And I would go x plus 9 and x plus 4, and then I would solve. It's easy. That would be easy. So the question we're asking ourselves is, can I find a way to modify that so that I can factor this thing that's x to the 4th? So I'm going to come back to the x to the 4th, and I'm going to say, well, I still like the 9 and the 4, because that still does that product of 36 and sum of 13 thing that I'm happy about. But what should I do to modify this to equal the x to the 4th? X squared and x squared. And it's still plus because there's nothing negative here. So I'm using quadratic form, which is I'm saying to myself, what if it had just been quadratic? What would I have done then? And I'm modifying it just ever so slightly to get it to be what I want. So if I were to FOIL these two things, I would get x to the 4th, and then I would get a 4x squared and a 9x squared. There's my 13x squared. And a 9 times 4 would be 36. So I'm good. I have factored. I'm not done yet, but I factored. I'm trying to solve this equation. That is my goal. So now I use the zero product property, and I say, alrighty then, one of you two things must have been 0. And these have to get solved. Here's the easiest way to solve them. They're not factorable. If they were factorable, you could factor them. But x squared plus 9, if it was x squared minus 9, then we could factor it, x plus 3, x minus 3. X squared plus 9, factoring the sum of squares is not possible. So instead, I'm going to say, well, let me subtract 9 from both sides. And then to undo the squaring, I'll take the square root of both sides. And you have to remember that anytime you take the square root of both sides of an equation, you get a positive and a negative root, so we do a little plus or minus. And then simplify, like do whatever you can to simplify. In this particular case, 9 is a perfect square, so that would be 3. And then I added the I in there for the negative sign, so this is plus or minus 3i. So there's part of my answer. And then I'll do that again over here. X squared equals negative 4. Take the square root of both sides, and I get plus or minus 2i. So I have 4 answers for this 4th degree equation. I have positive 3i, negative 3i, positive 2i, and negative 2i. Again, at this stage here, when you take the square root, you just do whatever you can. If it's a perfect square, great. If it's not, you say to yourself, what's the largest perfect square that divides into that thing? And you simplify however possible. I'm gonna walk through another one similar to this. Okay, so this is a 4th degree trinomial, no common factor, that I've said, hey, let me use what I know about quadratic form and try to modify what I know to get to the 4th degree. I'll show you another one that's very, very similar. Number 2. X to the 4th minus x squared equals 72. If you want to tune me out and try it, you just go for it. Step 1, make it equal 0. So I'm going to move the 72 over. Great. Now again, this is a 4th degree, it's a trinomial. So like for a moment I just say to myself, oh, if it was quadratic I would just do that product sum thing. So I'm going to just do that product sum thing. So I'm looking for numbers that multiply to negative 72 and add to negative 1. And that's going to be negative 9 and positive 8. So when I write my factors, I have to make sure that I write them in terms of x squareds so that I get the x to the 4th I'm looking for. So minus 9 plus 8, and I am factored. This is an equation, so I'm solving. So I'm going to go that one step further. X squared minus 9 equals 0. X squared plus 8 equals 0. Add 9. Take the square root. Don't forget the plus or minus. 9 is a positive perfect square. It's just plain old 3. Plus or minus 3. No i's. Wasn't negative. Alright, this guy I'll subtract 8. Take the square root. And then, as we've been doing for a while now, simplify this guy. So it's x equals plus or minus. I'm going to break that into 4 and 2. So that will be 2. And I for the negative sign. And a radical 2. And there are my solutions. All right, I'm going to give you guys one more to do, and then we'll try a different technique. Next and 4. Let's go minus 6x squared minus 72. All right, that's for you. Put one more after that, literally next to it. it's not a perfect square, the only thing it divides into is 2 and 3, so it's going to stay radical 6. But you can take the I out, so you're going to make it plus or minus to account for the square root, and then an I to account for the negative sign, and then radical 6 is just there are some numbers that cannot be simplified. Alrighty, so number 3 should be positive and negative 2 radical 3, and then positive negative I radical 6, and then one more of these guys. So this is x squared plus 9 and x squared minus 9. So here you're going to get plus or minus 3i and plus or minus 3. So far so good. Okay, let me throw one more up here in this category. X to the 8th power minus 20x to the 4th power plus 64. All right, so I would like you to take what we just discussed and see if you can apply it to this 8th degree thing. So like there's 2 stages of factoring. So you want to take like this in stages. So here comes stage 1. Stage 1 is, can I find numbers that have a product of 64 and a sum of negative 20? And in this stage, these guys are going to be x to the 4ths to get the x to the 8th. All right, so they're both going to have to be negative numbers to multiply to a positive number, but add to a negative. And the numbers are 16 and 4. So those add to negative 20 and multiply to 64. All right, now, I know it's tempting right now to go x to the 4th minus 16 equals 0. And, I don't know, 4th root it or something. However, you want to think about the last problem we just did. So the last problem we just did was an x to the 4th minus 81. And we did a difference of 2 squares, x squared plus 9 and x squared minus 9. So at this stage, I'm going to factor these further. I'm going to factor this guy. That's a difference of 2 squares. It's going to factor into x squared plus 4 and x squared minus 4. And then we're going to factor this guy. So finish that problem off. Once you get them to the stage where they're squared, then you can set them equal to 0. Don't try to do it before that. Alrighty, we have 8 answers here. Positive 2i, negative 2i, positive 2, negative 2, positive I radical 2, negative I radical 2, positive radical 2, negative radical 2. Alright, the moral of the story is this. Don't set anything equal to 0 until you've got it down to quadratic. 4th degree, don't set it equal to 0. You either have to do some more factoring or something. Now, I want to point out that you should always be on the lookout for a GCF. So I just want to suppose the original problem here had been this. Okay, suppose this had been the original problem. This one up top here, this guy right here. This had been the original problem. You should always, always, always be looking for a common factor. So if this had been the original problem, before you jumped in and started doing anything, you should have said to yourself, hey, there's a common factor of 2x here, and when you factor out the 2x, excuse me, you are left with 2x times this thing in parentheses. So that means this 2x would follow all the way through. Excuse me. And when you get down to the end, you would have yet another answer of 0. So always be looking for common factors as you're working through. Okay, be on the lookout for common factors. So this whole idea is using what you know about factoring things that are quadratic to factor things that are higher degree. Now that can get combined with the cubic stuff. Like we had a homework problem that was difference of 2 squares first, and then it resulted in a sum and a difference of cubes that you had to go further with. So things get combined. I want to show you one other different type of factoring that's going to feel familiar because it's kind of a subset of something we've already done. And then I've got some problems for you too. So we have discussed previously factoring by grouping. Now factoring by grouping comes up, I'm going to give you an example where it comes up. just as a reminder. So when we do problems like this, 6x squared, let's see, plus x minus 2 equals 0. All right, so we have factored lots of things like this. This is just quadratic. This isn't a higher degree, it's just quadratic. But when we factored things like this, we've said, I'm going to do my product sum move, but I have to multiply the 6 by -2. So we have to find numbers that have a product of -12 and a sum of 1. And then everybody knows the numbers are going to be +4 and -3. So this is when we said, great, that means you are going to turn into a +4x and a -3x. And the 6x squared remains, and the -2 remains. And here was where you heard me say the words factoring by grouping. Because here is where we go, oh yes, I'm going to find the GCF of each half of this thing, giving me 2x times 3x plus 2 minus 1 times 3x plus 2, and then I factor and solve. Great. All I really care about in this particular example is the factoring by grouping portion. When we were in the midst of all the factoring stuff that you were learning earlier this year, we said when you see four terms, when we're looking at these 4 terms here, we're factoring by grouping, right? So once we take this trinomial and break it into a polynomial with 4 terms, we factor by grouping. If you are faced with a problem that says solve by factoring, and there are 4 terms, you're probably looking at a factoring by grouping problem. So I'll give you one that's not like in the middle of that thing there. So here goes, number 1. A cubed minus 4a squared plus 3a plus 12. So the instructions are to solve by factoring. And I'm looking at this and I'm like, okay, there are 4 terms there. 4 terms. 1, 2, 3, 4. If you see 4 terms, you're going to go, hey, I probably got to factor this thing by grouping. Now, again, always looking for a GCF first. If there's a GCF, you should do that. There isn't one. So I'm factoring my grouping. I'm jumping right in. Here goes. Factoring my grouping. GCF of the first 2 terms is a to the second, leaving me with a minus 4. And then a 3, also leaving me with an a minus 4. Thank goodness, because if those 2 things aren't the same, then we have a problem. So my factors are a squared plus 3, a minus 4. So see how that was like just like what happened in that previous problem, right? The only difference is that this was a squared as a GCF, but same thing. Okay, we're going to set them each equal to 0 and solve. Don't get carried away. This guy's just a 4, no plus or minus or anything, because it wasn't squared. There was no square rooting happening there in that last term. So 3 answers: positive, I radical 3, negative, I radical 3, and 4. I'll give you a factoring by problem to do this. Number 2. Let's do that one. Alright, so I'm gonna give you guys some problems to do, and I want you to keep in mind, you should look for a common factor first, like every single time, just ask yourself, is there a common factor here? And then carry on. So here's what you've got to work with. You've got sum and difference of cubes formulas. You've got using quadratic form, meaning think to yourself, hey, what if this was just squared? What would I do then? And see if you can modify to make it work for the degree you're looking at. And then if you have 4 terms, you've got this little factoring by grouping. Sometimes the factoring takes multiple stages. Don't set anything equal to 0 until you have got it down in quadratic form. Otherwise, you're not going to be able to solve properly. Okay? All right. I'm going to give you a new sheet that has some good problems on it. And I'm just going to like put it right here for Josh to take a quick screenshot of. And I can't get them all up there at once, I guess. Okay. Nope. Almost had it. It's close. It's getting close. Ah, there it is. Alright. Josh, write those down or take a screenshot or something. I'm going to flip.